Hello, sixth graders. Welcome to your video lesson on prime factorization. Little vocab heavy, but if you think about the words mean, you'll be okay. So our learning targets are that I can identify numbers as prime and composite. You've done this, activate that prior knowledge. I can use prime factorization to determine the factors of whole numbers. Again, factors, we'll talk about that word. And I can express a whole number as a product of prime factors with exponents. So you're going to activate some prior knowledge of multiplying and dividing. You can do this. Okay, so vocab heavy page here. My suggestion is to sit back, engage, ask yourself questions, then pause at the end and maybe record some things. So vocabulary, a lot of it. What we know though is that every composite number, every number that has more than two factors, can be written as a product of prime numbers. Think about what that word product means. That means to multiply. And we know prime numbers are ones that have factors of just one in itself. So the product is the prime factorization of a number. So we use a factor tree, a little vocabulary, to pretty much break down a number by factors we know until all we're left with are the prime numbers that make up what we have. Notice, we did this different ways. This person started with dividing by 6 and 10, factors of 60. This person started with 12 and 5, also factors of 60. But we are going to end with the same numbers. Notice they ended just in a different order, but when we write it in prime factorization, we're going to list it the least to the greatest, and then if there are multiples, we'll write those with exponents, that repeated multiplication. So you'll have some opportunities here to be unique, and your end result should be the same, even if you pick different factors than I do. So some vocabulary here on the bottom, just to kind of break it down, that didn't come all at once. So prime factorization is breaking a number down into the set of prime numbers which multiply together to form a product of the original. So again, you're factoring, you're just breaking down the number until all that's left are the prime numbers. Product of primes, that's just when you write out those prime factors as a number sentence. So this would be like a product of primes. I'm multiplying to show that that makes 60. So it's my product of primes. 60 is my product. Those are my primes listed out. Factors, again, factors are whole numbers that multiply together to form another. So factors of 60 up here were 6 and 10, but also 12 and 5, all factors of 60. And lastly, a factor tree is used to break down a composite number into its factors until only prime numbers remain. So again, we just factored it, making a tree. Notice the branches, and then the numbers are your leaves, say. So that's the vocab. Maybe take a minute to pause and maybe say some of it back or try to put some things into a sentence to make sure you're ready to rock and roll. So here I'm going to show you two methods of how to find the prime factorization of a number. Method 1 is the factor tree, like you saw on the previous slide. Method 2 is dividing by primes. So let's show you. And remember, you're going to follow along. You might do this differently than I would, but if I start with 24, that's the top. It's more like when we say factor tree, it's almost like this is your plant and the roots are what's below. So personally, I'm going to start with 3 and 8, factors that I know make 24. Someone else might have done 2 and 12, and that's totally fine. You're not using 1, because remember, 1 is not prime. When you get to a prime number like 3, and you can't do that anymore, so don't do this, 3 and 1, because you're just going to end up with 3 again. You are going to stop there right at 3. I know that's prime. I'm going to circle it. That's a prime factor. Go to 8, and I'm going to factor that. Well, 2 times 4 is 8. 2 is prime, so I circle it. 4 is not prime, so I'm going to continue. It's 2 times 2. Both of those are prime, so I circle them. So again, you keep dividing the numbers until all you have left are primes. Then you could write this out as, notice I have 2 times 2 times 2 times 3, which is the same as 2 to the third power, right? Repeated multiplication times 3. You'll notice I'm using a dot much more than I will use an X, remember, because later on you're going to see algebra, and you don't want that X to get confused. Other method, dividing by primes, is exactly what it sounds like. We'll still start with 24, and we kind of create an upside down division there, and we're going to divide by the lowest prime number we can think of first. So this is more, you go in order. So the smallest prime I know is the number 2, and this goes in there. Then I get 12, So I divide that by the lowest prime, which is 2, end up with 6. The lowest prime is 2. I get 3. The lowest prime of 3 is 3, so ending in 1. So when you division by primes, you do want to end up, this is how you know you are done. And then noticing these were the numbers I divided by, well, then those would also be the numbers that I could multiply by to get to 24. So a good way to check it, when you write this out, 2 times 2 times 2 times 3, if you did do that, check it back. Well, I know this is 4 times 2 times 3. Oh, that's 8 times 3. Oh, I do get 24. So this is a good checking way. So either way, this is the ultimate way to write the prime factorization of 24, or writing it as a product of primes. Okay, if you're feeling comfortable, I just did that one for you. Why don't you try both methods here and then come back and check. Using a factor tree, and again, remember yours might not be the same as mine because you might pick different factors. Someone might pick 3 and 6. Someone else might pick 2 and 9. I'm going to go with 2 and 9. 2 is prime. There's a tricky one. A lot of people say 9 is, but we know that factors of 9 are 3 times 3. So both prime there. I'll write my final answer at the end after I show you my division of primes. So again, 18. Lowest prime is 2. Lowest prime is 3. This is where some people forget. You have to do that last 3 until you get to 1. So then notice your answers. On either side, we had 2 times 3 times 3. They're both the same, right? Same number. So I can write that as 2 times 3 to the second power. That is the prime factorization of 18. So now here we have find the product of primes using either method. So remember, product of primes is another way to say we want to list the primes with multiplication. So we're really using prime factorization. But product of primes, remember that's just we're multiplying all the primes until we get to that number. So try either method. And this first one, because it's so large, I'm thinking I'm going to use a factor tree. Because it ends in a 5, thinking about my divisibility rules, I know it's divisible by 5. But I may not know off the top of my head, so I might have to do some division, long division on the side down here. So I did 285 divided by 5, knowing that 5 goes into 28 5 times for 25 with 3 remaining. So then it goes into 35 7 times with none remaining. So I know 5 times 57 gives me 285. A little tricky, sometimes that's not a common one, so I circle my 5 because I know it's prime. Some people may jump here and say, oh, that's prime too. But what I notice is this is very close to 60. So I think about my divisibility rules too. I know that 5 plus 7 equals 12, and 12 is divisible by 3. So then 57 also must be divisible by 3. A little trick there. So, and I also could look at it too. I know it's close to 60, and I know 60 minus 57 equals 3. So, and I know that 60 divided by 3 is 20. So that's 1 less. So I know that this is 3 times 19 gives me 57. So again, there's not one right kind of way, but as long as you are acknowledging what do I know to help you with what you don't know yet. So the prime product of primes for 285 would be 3 times 5 times 19. Notice how I ordered them least to greatest there. So since I did a factor tree, I'm going to do a division by primes on 180. And maybe you did it different, so maybe I'll show you kind of both too. So I'm going to start with my lowest prime, which is 2 since it's even. I know 16 divided by 2 is 8, so that must be 80. Divided by 2 again, we get 40. Divided by 2 again, we get 20. Divided by 2 again, we get 10. Divided by 2 again, we get 5. And again, we have to end at 1. 5 divided by 5 is 1. So one thing, that one kind of written out, I see that I have 2 times 2 times 2 times 2 times 2, 5 times another 5. So I can write that as 2 to the 5th power times 5. A great method too, if you would have chosen the factor tree, with that what I might try is because it ends in a 0, I know that's a nice easy 10 times 16. And I could have done just as easily done a factor tree and listed my primes the same way. But notice this one just maybe gets a little disorganized, whereas when I do the division by primes, they're in order for me already. So again, pick a preference that works best for you, but this would be listing out as my product of primes. So where it gets interesting now is we are going to do prime factoring for an algebraic expression. So remember, algebra is the branch of mathematics that uses letters in place of numbers. So when numbers and letters are next to each other like that, remember it's multiplication. We have multiple ways to show that, right? We could do this. We could put them in parentheses. But when there's variables, we can also just write them right next to the numbers. So this is multiplication. So I'm going to use my factor tree. I know this is 18 times C times D. Well, C and D are their own separate numbers. So I'm actually going to make 3 branches to start. 18 times C times D. And then once, because we don't know how much further these go, we are going to circle those as their own individual primes. And then maybe for 18, I do 3 and 6. And then I'm going to list that out. So I know that is 2 times 3 times 3 times C times D, also known as 2 times 3 squared times C times D. That is the prime factorization of this. Same thing for now, 50 times x squared times y squared. I'm going to split up 50 times x squared times y squared. Split them up because we can divide them if they're being multiplied. 50 I know is 5 times 10 and 2 times 5. X squared, remember squared means a number times itself, so this is x times x. And this is y times y. It's treating them as numbers. And so then I can write that out, listing as 2 times 5 times 5 times x times y times y. That is the product of primes, also written as 2 times 5 to the second power times x to the second power times y to the second power. Last but not least here, you are now kind of working backwards, and you might try this differently than I do, and that's super okay. Share that with us. What I know is that if I multiply numbers to get a product, I could then divide that product by those factors and get my other factors. In this case, so that's one thing. You could multiply those together, and I know this is 4 times 3, and I could really divide this by 12 to figure out the rest and then find the factors of that. And you're feeling up for that, go for it. I'd love to see your creative thinking. What I know is I'm looking for this. So I'm just going to factor out the 1500 as normal. So I see that 100 times 15, because I know that 2 zeros at the end. And I factor that, well, this is 3 and 5. I know that this is 2 and 50. I know that that's 2 and 25. That's 5 and 5. So multiplication charts might be helpful, but I think this should help too with your basic facts and kind of refreshing those to be on quick fire. So here I know my 2's were accounted for, right? I know that's 2 times 2, and I had a 3. Then I also had 3 5s, 5 times 5 times 5. And that's really how it should be written out, right? Least to greatest. But what I noticed then is that what I was missing in that box was my 5 to the third power. And of course, you can multiply those back through to make sure they get to the correct product. On the other side here, what I might try is a division by primes method instead. Noticing it's even, I might just keep dividing by 2 until I'm maybe uncomfortable with that. I could have divided by 3 there if that was easier for me. Like on this one's even, 150, but easier for me is dividing by 3, and that's okay. It's just not going to be as in order anymore. And then I get to the end here, a 1, and then I list those out. And again, if you're chasing me, you're not engaging. So remember, pause and watch, or try on your own and then come back. So I have 1, 2, 3, 4. 2 is just like it set up there. Times, I have 1, 3. Then it looks like I have 2 5s. So 5 to the second power is my missing piece. And then, of course, I could multiply those together to check. All right, you've done great, students, and I think now it's time for you to try in your notebook. Try these out, and then we'll check them out. from there. So using a factor tree or division by prime. So you don't necessarily have to use the factor tree. I want you to show me, though, you're thinking of writing it out. What is the prime factorization or the product of primes of 34? The algebra one, try it out. No stress, right? Treating each of these as their own numbers. Writing the factor tree of that. And then find the missing prime factor that goes here. Can't wait to see your work. Look back over your notes. Hey, explain the concepts to someone in your family or a friend. Talk through it with each other. Using the vocab always helps. Rewatch a section you need to, and look forward to keeping practice up. There's an IXL that goes along with this. See you soon.